This type of problem asks us to identify if the equation is linear or nonlinear. If you're unable to recognize the three forms of linear equations, which is slope-intercept form, point-slope form, and standard form, then one method you could always use is to create a table of ordered pairs. What I'm going to do is I'm going to look at the values of 0, 1, and 2 for my x values. I'm going to plug those in and use the equation to determine what the value of y will be. So when I plug in the 0 for x, I get y minus 4 equals 3/4 times 0 minus 4. Well, 0 minus 4 is negative 4. Right here I get negative 4. That times 3/4 would give me negative 3. So now I have that y minus 4 is equal to negative 3. When I cancel out the negative 4 with a positive 4, I get the value y is equal to 1. So now in my table, I'm going to record that the y value is 1 when x is 0. When I repeat the process, plugging in 1 for my x value, I get that y is equal to 1 and 3/4. When I repeat the process, plugging in 2 for my x value, I compute and I end up getting that y is equal to 2 and 1/2. Now what I can do is look at the changes. I know that my x values are each going up by 1, so I'm going to place those in the bottom of my ratio for slope because the change of x goes on bottom. Now I'm going to find the changes of y. From 1 to 3/4 is going up 3/4. From 1 and 3/4 to 2 1/2 is going up 3/4. Now, whenever I reduce each one of those fractions, I see that I get 3/4 over 1 is 3/4 in both cases, and I see that my slopes are the same. So therefore, this is a linear function.